This is my third video lesson for the Ionic Bond unit. In this lesson, we'll be learning how to draw Lewis dot diagrams for atoms and ions. So let's go to page 8 in the class packet. Motivation. In this diagram for chlorine, predict what the dots around the Cl mean. This is a new model that we are going to talk about. It's called the Lewis dot diagrams. These dots do stand for electrons, but not all of chlorine's electrons. It only stands for the valence electrons. Learning target. At the end of the lesson, I'll be able to determine the Lewis dot diagram of both the element and its ions. There'll be a homework number 3 Junipod based off this lesson. There'll also be a quiz Junipod based off this lesson and the previous 2 PowerPoints. Lewis dot diagram is a model used to show the valence electron of an atom. This model in particular is used in bonding. That's why we only care about the valence electrons, not the inner electrons. So here we have an atom, chlorine. Chlorine has 7 valence electrons, so we draw 7 dots around chlorine. Check of understanding number 1. What is the maximum amount of dots that can be placed around an element? If you look at the periodic table in your reference table, under noble gases, notice that each of the electron configuration of the noble gases, the last number is 8. If you recall from previous lessons, atoms bond to have the same configuration as the noble gases. Therefore, the maximum of dots that can be placed around an element is 8. Here is Gilbert Lewis. He was the one who created the Lewis dot diagram. Now I'm going to do an example of a Lewis dot diagram. So what is the electron configuration of oxygen? If you look at the periodic table, it is 2, 6. How many valence electrons does oxygen have? That's the last number, so it's 6. So first, you draw the symbol of oxygen, which is O. For placing electron dots around the symbol, the normal chemistry is to place them in pairs on each side of the symbol. Now I'm going to place it for oxygen. So oxygen has 6 valence electrons. I'm going to place those 6 around oxygen. So this is considered correct. You can also pair up these two as well if you want to. For example, like this. This will also be a correct Lewis dot diagram of oxygen. So either this or this would be fine. One way of remembering this norm is think about a table with these chairs placed around it. Learning trick number 1. Which Lewis dot diagram represents a nitrogen atom in the ground state? Pause the video and resume once you have the answer. By looking at the periodic table, nitrogen has 5 valence electrons. Therefore, nitrogen should only have 5 dots around it. So the answer is choice 3. Learning trick number 2. An atom in the ground state contains a total of 5 electrons, 5 protons, and 5 neutrons. Which Lewis dot diagram represents this atom? Pause this video and resume once you have the answer. So this is a tricky question because it says a total of 5 electrons. These 5 electrons are not valence electrons. So you must remember in the first shell are 2 electrons, right? So as a result, there's only 3 valence electrons, not 5. So the best answer is choice C. In this practice, you'll be drawing Lewis dot diagram for all these elements. I'm going to do period 2 as an example. So lithium has 1 valence electron, so you're supposed to draw 1 dot. Beryllium has 2, so you draw 2 dots. Boron has 3. Carbon has 4. Nitrogen has 5. Oxygen has 6. Fluorine has 7. And neon has 8. If you recall from the periodic table unit, you should know within the same group, the elements will have the same valence electrons. So sodium and potassium will all have 1 valence electron. Same with hydrogen. Now I'm going to compare atoms and ions. Atoms will bond to obtain a stable valence electron configuration. In the context of ionic bonding, they'll transfer a valence electron. They'll either gain or lose. By doing so, they become ions. There's 2 types of ions, anions and cations. Anions are formed when the atom gains electrons, and cations are formed when the atom loses electrons. So anions are negative, they're larger than the atom, and typically nonmetals become anions. For cations, they're positive, they're smaller than the atom, and typically metals become cations. So now we're going to draw the Lewis dot diagram of nonmetal ions. Here is the Lewis dot diagram for nitrogen. Nitrogen has 5 dots, right? So following the octet rule, in order for nitrogen to achieve the noble gas configuration, it needs to gain 3 more electrons. So let's draw 3 more dots. Now nitrogen is an ion, but what's the charge of this ion? Since it gains 3 electrons, the charge is -3. So we're going to put brackets, then the charge. On the regions, it's very easy to determine the charge of each element. On the periodic table, you see a list of charges. It's just the first one. Now we are going to talk about metal ions. So let's do an example, sodium. So sodium has 1 valence electron, so we draw 1 dot. And since it's a metal, it's going to lose that electron. So when it does, which one is the correct Lewis dot diagram for that ion? Or which one is better? So it turns out this one is better. Even though sodium, when it loses that valence electron, has 8 valence electrons, technically, this is inaccurate because when someone looks at this, they assume sodium must have gained 7 electrons rather than lose 1. So for metals, you don't draw any dots. Let's review the rules. Let's start with nonmetal ions. So all ions must show charges. For nitrogen is -3. Check the oxidation numbers for the ion charge. So on the periodic table, these numbers over here are called oxidation numbers. I'll discuss what they are in the future, but for now, just pick the first number. That'll be your charge. Nonmetal ions always show 8 dots except for hydrogen, because hydrogen just needs 2 electrons. Nonmetal ions must be in brackets, so you have to put the brackets. The charge goes on the top right corner of the brackets. For metals, they have similar rules. All ions must show charges, so lithium is charges +1. Check the oxidation number for the ion charge. You can only do this for group 1 and 2 metals. Okay, I'll explain why that's the case in the future. No dots are shown for metal ions. Metal ions must be in brackets, and the charge goes on the top right corner of the bracket. So now I want you to draw the Lewis dot diagram for these ions below. I am going to do 2 examples. You can do the rest on your own. I'm going to do 1 metal and 1 nonmetal. So I'm going to do magnesium and oxygen. So magnesium will have a +2 charge. And for oxygen, you will have a -2 charge. So let me draw 8 dots around oxygen. And the brackets. Learning check number 3. Which Lewis dot diagram is correct for S-2 ion? Pause the video and resume once you have the answer. Okay, so since sulfur, which is S, is a nonmetal, it must have 8 dots around the symbol. So the only one that has that is choice C. So that's the answer. So this concludes the video lesson for today. Remember to do the Junipod homework and quiz.